Welcome everybody. Today we are on section 10.1. We are talking about arcs and sectors. So today we're talking about central angles to start us off. So a central angle is an angle that's going to have its vertex at the center of a circle. And then these two sides of that angle are the radius of the circle, or since we're talking about two radiuses, we don't say radiuses, we say two radii. Radii of the circle, which just means multiple radiuses. I said radiuses, but because I'm trying to say it correctly, right? So let's fill this in. Central angle is an angle whose vertex is at the center of a circle, and its sides are radii. The sum of the central angle in a circle is, well, if you add up all the angles around, if you go all the way in a full circle, we call that a 360. So the sum is 360 degrees. Example. I don't know what that is. I should have pre-looked. I don't know what the example is. I don't know. I guess an example of things that add up to 360, 300 degrees and 60 degrees. I don't know. Something like that. Ask your teacher. I don't know what's supposed to go there. Hopefully I'll know when we actually go through it. All right, the next part here. The degree of the arc formed by the endpoints of a central angle is blank to the degree of the central angle. What that is saying is an arc, which we didn't really talk about what an arc is, but see how this radii comes out and grabs point A on the circle? And this radius comes out and grabs point C on the circle? Well, this line segment right here that's kind of like curved, we call that an arc. So this is arc AC, which we would write like this, arc AC. That arc also has a degree measure, and that degree measure will always be equal to the inside of the circle. So you can see that this angle is 84 degrees. That means the arc AC is also 84 degrees. So the central angle is always equal to the arc. They have the same measure. On the outside, you can see that there's another arc, but this one's a really big arc. In fact, we call AC a minor arc because it's smaller than half the circle. In other words, it's smaller than 180, our most important number in geometry. So if the arc is less than 180, we call it a minor arc, meaning you will label it like this, 2 letters. If we are talking about an arc bigger than half the circle, which means it's bigger than 180, we're talking about what we call a major arc. Here's the problem. If I asked you to name this major arc, you would also say it's arc AC. Well, then how would you know if you're talking about this one or this one? So what we did is we added an extra rule. Whenever it's a major arc, instead of using 2 letters, you have to use 3 letters. So over here, I would call this arc ADC, because then I know that I can't just go AC, I have to go A all the way around to C so that I pass D. So right here it says, what's the measure of arc AC? We already talked about that. If this is 84, then arc AC is 84 degrees. Since I know the whole circle is 360, I know that this angle right here, this really big angle, is going to be 360 minus 84. So when I do that, I get 276, which means that arc ADC, major arc ADC, is also 276 degrees, so that the whole circle can add up to make 360. What's going to be important today is that you keep in mind all the rules we've learned throughout the year about angles, that straight lines make 180, that vertical angles are equal to each other, that 90-degree angles are complementary angle pairs. All those things are going to be super helpful. Supplementary pairs make 180, those things, right? So right here, if you look at example 1, the first thing you should jump to is say, hey, I know that this and this are vertical. So if angle JNK is 21, then angle MNL also has to be 21. Likewise, this is definitely vertical to this, which means since JL is a straight line, I can find KNL by subtracting it from 180, and I would get 159. And since they're vertical, I also know this is 159. Now you can go and solve all of this really easy. The measure of arc JK, well, I don't know the measure of arc JK, but since JK is being intercepted by the 21 degree angle, I know that JK is also 21 degrees. The measure of angle JNM, that's the one we found right here, 159 degrees. The measure of arc KL. Again, KL is being intercepted by angle KNL, so we are going to use the 159 degrees for that as well. Angle JKM. Ooh, look at that. JKM. So we're using all of that. So 21 and 159 is 180, plus another 21 is 201. Notice how I added all of that together. 21 plus 159 plus 21, and that made JKM. Also notice that I didn't go JKM. JKM, that's not an arc. You got to stay on the circle. So J past K and keep going. It'll pass L too, but then it'll eventually get to M. And last, I've got MKL. Oh, that's a lot of the circle. Again, it's not MKL. No. MKL. No. M all the way around to K, then to L. So I can see that's all of the circle except the 21 degrees. So the easiest way to do that, you could add this plus this plus this, or you can take 360 and subtract 21. And I would get 339. So 339 degrees. All right, shimmying that on down. Number 2, same idea. We got this the circle with all these angles in it, and we got to fill it in. I would come to these questions later. Fill in your circle first. One of the things that I see right away is this arc is 72 degrees. That means this angle is 72 degrees because they're central. And then this WU is a diameter of the circle, the straight line that goes across. So I know that has to add up to 180. So I can take 72 and 87 and add them together to figure out what I'm using already. 159, which means whatever's left over has to make up 180. And I can see that if I subtracted that from 180, I would get 21. So this has to be 21. Again, if you want to take this extra step, you could do that. We know this is 21 degrees then, and we know this is 87 degrees then. Next, I'm gonna have to use my vertical angle. See how 72 is vertical here? This makes a perfect X. So if this is 72, I know this is 72 degrees, which again means UV is 72 degrees. And then you could do a lot of things. Some people might see that 21 and 87 are vertical to it. Some people might take 180 and subtract 72 from it. Some people might add all of this up and subtract it from 360, whatever you want to do. I think the easiest is that this is 180. 72 plus this angle has to make 180, so I take 180 and subtract 72 from it. 180 minus 72, and I'm going to get 108. So I know this is 108, which means this arc on the outside is also 108. Now they're easy. Find UXV. UXV is going to be 72 degrees. Find the measure of arc ST. Arc ST, 21 degrees. Find the measure of arc WV. WV is 108 degrees. Find the measure of arc TW. TW makes up two things, right? You can see there's two things, 21 and 72. So I'd add those together. 1 and 2 makes 3. 2 and 7 makes 9. So 93 degrees. And of course, lastly, TVW. To get to W, I can't go that way. So I got to go TVW. So it includes all of this. 87 plus 72 plus 108. 87 plus 72 plus 108. Add that all up, and I got 267. Of course, you could also subtract the 93 you got right here, and that would give you the same answer. All right, let's throw some algebra on this, okay? Let's step up our game a little bit. Now it just wants me to solve for x, so I'm gonna have to think kind of critically about what's going on here. This shouldn't be too complicated either, because what I can see is, hey, if this is 103, this angle is vertical to both of these angles put together. And I see that this is already 15, so that's gonna be 15. So really what I know is what goes there is gonna take 103 and subtract 15 from it. So if I take 103 and subtract 15, I get 88. And now 88 plus 15 equals the 103. Now I can go ahead and set this equal up here. I know that the 88 matches up here, so I find that 18x minus 2 should also be 88 degrees. In other words, 18x minus 2 equals, why did I put an 80? 88. And we're gonna solve that. So I'd add 2 to both sides. I get, this cancels, I get 18x equals 90. divide by 18, divide by 18, and I get x equals 5. So just use some critical thinking skills and you can find these problems using all your angle rules from the past. So let's add in another thing that we're gonna do here. What if I said to find the length of an arc? Instead of just finding the degree, the measure, keep in track those words, right? Earlier, when we found degrees, this was the measure of the arc. 87 degrees is the measure. 72 degrees is the measure. If I say find the length, I'm asking you to find like how many feet, how many inches, how many centimeters, how many kilometers is it? They're gonna be a little bit different. The length is just a proportion of the circumference. If you know the circumference formula, you also know the arc length formula. Arc length, or we like to use L for it, arc length is determined by taking the circumference, which your circumference is 2 times pi times the radius, 2 pi r. Find the entire circumference, but then multiply it by x over 360 degrees, where x is equal to the central angle. So what I'm doing is I'm taking the central angle and dividing it by 360 to figure out what portion of the circle we're using to find the arc length. So you're taking the measure of the arc, the degrees of the arc, and dividing it by 360. Then finding the circumference and multiplying those things together. This should always give you a decimal less than 1, every single time. Something less than 1, like 0.63 or 0.728 or 0.396, something like that. It's gonna give you a decimal. So let's look at this one. It says if VS is 12, V to S is 12. Well, what does that tell me then? VS is from here to here. That means the diameter is equal to 12, right? Here to here is the diameter. And if that's 12, the radius is half of that, which is 6. That's gonna be super important. It says find the length of UT. Here is UT that I'm finding the length of. Well, if I'm gonna do that, the first thing I'm gonna need is I'm gonna need to know the measure of UT. I need to know the measure of arc UT so that I know how many degrees to plug in for X. So I'm gonna have to work through it just like we did the last one. What it looks like is because this is a straight line, I know that these together have to make 90. And I can see that this is a straight line, so these together make 180. So I can take 127 and subtract it from 180. And I'm gonna get 53. So I know this angle is 53 degrees. That would make UR equal 180. And now I can make this add up to 90 because I'd take 90 and subtract 53 from it. And I would get 37. So now I know the measure of arc UT is 37 degrees. Now I can actually solve for the length. The length is equal to x over 360. I know that x in this case is 37, so I put 37 over 360. Multiply that by 2 times pi times the radius, which we said was 6. So I'm gonna put this as 2 answers. We may need the exact answer, and we may need the rounded answer. So let's start with exact. Exact means you're not gonna multiply by pi and you're not gonna divide the fraction yet. You're gonna leave everything as whole numbers. So 2 times 6 is 12. So I get 37 over 360 times 6 times 2, like I said, is 12 pi. We're gonna then multiply that to our numerator. 12 times 37 is 444 pi over 360. And we would just check if that reduces, which I mean, it definitely is gonna reduce by 2, right? We can definitely get that to reduce by 2. Actually, something bigger definitely goes in. 12. It is 12, yeah. 444 divides by 12 and gives us 37. So this becomes 37 pi. 360 divided by 12 is 30. By the way, again, what I did here, that's kind of a tough one. Divide by 12, divide by 12. But I get 37 pi over 30. That is the exact answer. You may be asked for that in the FSA. But what we're probably gonna do a lot of is finding the rounded answer, which means we just put it in a calculator, right? In a calculator, I would go 37 divided by 360 gives me the decimal 0.102, blah, blah, blah. Don't take it out of your calculator, leave it in there. Times 2, times pi. Make sure you read what they want you to do. Sometimes it says use 3.14 for pi, sometimes it says use the pi button. I'm gonna use the pi button for this because it doesn't say. And then times 6 equals approximately 3.87. And check your units, we were in meters. I should have put meters up there too, but I didn't. There, meters. And that would be how we find both of those answers. Both are correct, both are acceptable, just depends on what they asked for. Since our directions here didn't ask, I did both. But make sure you can work through both of those. I think, like I said, a lot of people struggle with simplifying the fraction, but that's where you get. In fact, a lot of your calculators, though, can do this. If you have this calculator on the test, you can do it. 444 fraction is this ABC button right here at the bottom. ABC, 360, 360. Press equals. Now that tells me it's 1 and 7/30ths, but I don't want a mixed number. So I'm gonna press second, and the fraction button again, you can see above it says D over C. It's gonna turn it back into an improper fraction. 37 over 30, 37 over 30, and keep the pi on it. All right, example 5. This one is asking me to go ahead and if JH is 21, J to H is 21, again, that's the diameter then, so we're gonna make that note. The diameter is 21 inches. That would mean the radius is half of that, so 21. Okay, so I don't know quite where I left off, but I know I was dividing by 21. There was an interruption with the announcement. I paused it. So we're gonna take that 21 divided by 2, so we have the radius is 10.5 inches. So those will come in useful later. All right, so coming up here then, they asked me to find the length of arc KJG. KJG, all the way over here. Done. Well, you could do a lot of work here to figure out how many degrees that is, or you can figure out, oh, I'm not in the picture, I'm sorry. You can figure out how many degrees it's not. Arc KJG just doesn't include minor arc KG. So let's just figure out how big minor arc KG is and subtract it from 360. Don't make that too much work. And that's easy, look. This is vertical to these two angles put together. So 85 equals, those two equals 85. So really all I'm gonna have to do is do 85 minus 59. And when I do that, I'm gonna get 26. So I can see that arc KG is 26 degrees, meaning arc KJG is just all of that that's not 360. So 360 minus 26, that's gonna give me 334. So I can see that the measure of arc KJG is 334 degrees. So again, let's just plug in the things we need to. I know that the measure of the arc is x, so 334 over 360, multiplied by 2 times pi times the radius, which is 10.5 inches. Again, two answers I want to put here. The exact answer would involve me multiplying the numerator by 2 and 10.5. So 10.5 times 2 is the 21 again. 21 times 334 is 7,014. So this is gonna be 7,014 pi over 360. That is really big to simplify, but again, use your fraction button. 7,014 ABC 360 equals, I don't want to mix numbers, so second fraction again, 1,169 pi over 60, and it was what, inches? Inches. Boom, there's the exact answer if they ask for it. Obviously though, we can just find the rounded answer as well. 334 divided by 360 times 2 times pi times 10.5. And I get 61, rounded, is approximately 61 point, and let's see, 208. So the 8's gonna cause the 0 to round up, so 2, 1. I always like to round to hundredths places. I think it's just a little bit better. There is my second answer. Again, both are good, both are correct. Depends on what it asks. Just find the exact answer or leave it in terms of pi. That would be the answer I want. Ignore that bell. That would be the answer I want, but if they want the round answer, that's good. So both are good. Hope that helps. Let us know if you have any questions. Bye, everybody.